JSON, we can, I wanted to make this a Ask Me Anything regarding JSON. And if people are interested, I've also brought the demo we showed at Code One at Open World. It's about application development, the new Node and Python drivers. So I wrote a little web application in Node.js that makes use of JSON in the Oracle database, and also some Python to do analytics and visualizations. All right. So in one of the last Ask Tom about JSON, I've already shown this soda layer, simple Oracle document access, where we have a NoSQL style API on top of the Oracle database. And for a few weeks now, we have new drivers for Node.js, which is kind of JavaScript, and for Python. So for Open World, I wrote a demo to show how this works. So this is in addition to the existing REST and Java drivers, which we already have. There's also a PL SQL driver, but I didn't include that in the demo. So let's share my screen here. Just like a brief introduction on how this is running. This is all installed on my laptop using Docker. So I have one Docker image running the Oracle database. So it's running the 18.3 version of the database, and that is the one you also need for Node and Python, because you need the client libraries for 18.3. And then I have another Docker where I run the application code, which is the Soda drivers. And we start with this Node.js program. So I used to always ask if people are familiar with Node.js, but here nobody's talking to me, so I can't ask you this question. So this is basically boilerplate Node.js that uses the Express framework. We're writing a simple application, and most of this is really, I think, very familiar to people who know Node.js. So what we do here is we include this Oracle DB. This is the new drivers for Node. This gives you access to the Oracle database. Then we include this DB config. That is basically just to connect information to the database. So we have the database listening on this host name. It's a PDB database, and this is just the schema name and the password. And then we turn this to auto commit true. And then basically this is just some stuff for Express where to look for files. And then we start the server. This is basically here. And what do? We start the server listening on this port, and this is the stuff that interests us. We basically get a connection to our database. We get the Soda driver, and then we create a collection called survey. So to explain a collection, this is basically a bag of JSON data, which is internally mapped to a table. But you don't have to use SQL to create the table. Instead, it's sufficient if you just say create collection survey. So let's start the server here. And now I should be able to refresh this window here. And I see that there is this is the web application. So this uses Oracle Jet as a front end. This is similar to, what are these terms? Angular or React. I'm not an expert on these things at all. To me, this is just some mechanism to make the user interface more beautiful. So we're listening. This is an Express application, so it means it listens to REST requests, and each request is backed by some operations. So if we basically call this /reviews URL, we will go to our collection and find documents. And similarly, if we do a post on reviews, we can add a record. So let's do this now. There is this ad here, and this demo was about a market survey around candy. So we have different candies, which are different colors, and people can give us some feedback on how sweet and bitter they find this in this tasting, and how much money they're willing to pay for a box of these. So let's say this person finds the blue flavor pretty sweet, not too bitter, and is willing to pay $9. Then we generate a piece of JSON here. This is the record reflecting all the data we've just entered. And this is sent into our collection. So let's take a look at our code back here. That's not the one I want. I want this window here. So we do a post to reviews, and this is a new document. So we use insert one and get. Reviews is the JSON we just saw. And insert one and get means we're inserting this document and we get a key back, the key that's been assigned as this document. So we're extracting the key out of this doc and we send the new key back, and this is what we're seeing here. So that's the key that has been assigned to this document. So this is a key value style API. This is the key, this is the value. We could also generate the key from our application, but in this case, it's just easier to let the database do that. So now if we go back to our main page here, we now see that there is this one record with a new key, and we see the properties that were assigned. So I could also do show JSON, and now we see these are the arguments, and this is the key that has been assigned. So let's go back at the code and see. Yeah, we could do an update. So this was the code path for insert one and get, but the same callback has a condition here. If an ID is provided, then don't insert a new one, but instead go to our collection, find the document based on this key and replace it. So what we could do is we could go to edit and add a little comment here. We submit it, and we see that the record has now the comment field, and the response is that our field got updated, and now we see this. We see that the comment has been reflected. So, and this is basically just handled by these different cases here. Now, since this is a collection, I would be able to also use SQL to query it. So we see our, if we go back to our test server, the collection was called survey. So this was the name we gave our collection, and internally it's mapped by a table. So the table here has the ID column. Maybe let's just clean this and rerun the describe. Then we only have one statement there. So it has these, 5 columns. One of them is the JSON document where we store JSON as a blob in a binary representation. We have the version, the last modified, the created on, and the ID. So now if we print this, I use the to-glob to convert the blob into a CLOB textual representation. We see that this is our data inside of our collection. So now let's say, why do we do this? Why don't we use SQL to insert our data? Well, in SQL or in a relational design, you would probably have columns for your flavor and the sweetness and so on. Whereas with JSON, you can easily add fields as you go. So let's say we wanted to capture an additional field. Then let's say the field is, we have bittersweet. Let's say there is some fruitiness. So I want to add another field here. All I have to do is in our page where we add the new comment, we need a new slider, or we have to basically modify our UI. I have prepared this already, so I just need to uncomment this. Then whenever we add it, when we generate the JSON, we have to also add this new field. I'm just calling it fruity. I think there was let me just move this up here. Yeah, there's another one here. This is just for insert and update. And in our table, we also want a new column for fruitiness. So now all I do is I save it. I don't have to restart the database. I don't have to alter the database. There's no alter table. I don't even have to restart my application. There's one typo. I always do the same typo here. I think it's on this page. There it is. This comma has to be there. Otherwise, it's not syntactically correct. JSON. So now here we have our additional slider for fruitiness. So again, I didn't have to change anything besides the application. Didn't even have to restart it. Database is just accepting a new JSON record. So now if I have a new record, we see that this new field fruity just magically appeared. It's being stored in the database. And if I go back to my SQL here, we should see a second record that has this new field which didn't exist so far. So what I've shown here is that schema evolution is quite easy. Adding fields as you go is not a problem. But what happens if the developer adds many fields and you don't know what fields are in use, or if people have used fields which they should not have used, like social security number or credit cards number? You could look at all these fields manually, but imagine you had thousands. This would take way too long. So instead, you could just use the database to calculate a data guide. So the data guide is a summary of all the fields that occur in all your rows and all your JSON data. It's not printed nicely here. So let's just go to pretty printer here. And what is this? Let's just validate it. Exactly. And we see here that in our data, across all our rows, we have a field called price. Strangely, it's a string. I would expect it to be a number. This is probably because I don't convert the input price to a number in my JavaScript. But then we have the numeric data for sweet, for bitter, for flavor, for fruity, and the comment. So we see all the fields that occur in our data. So now if I would change the program and add additional fields, all I would have to do is calculate the data guide here, and I would see these. So now, since we use the Oracle database, we can use just plain SQL to select values from our collection. So this is just extracting the fields of flavor, or we could easily just do order by, group by. This is just to show that although you've used a NoSQL way to access your data, you can still use SQL to query it. So if we go back to the application, there is, let's just add one more record here. Let's say $7 and another blue. So we have a third record here. So let's say I don't want to use SQL to query the data. So instead, we use something what we call query by example, which is basically writing the query in JSON itself. So I've added this filter field here, and I can say, show me all the documents which have a field flavor and the value be blue. So I use this, and I see only the blue document. So this is basically using JSON to query your data instead of SQL. And I have another one. So let's say you wanted to look for all the fields where the price is greater than 9. Well, there is no one. Let's say 7 here. So you would write it this way, the price, and then it's the price itself, its value is an object, and then this $GT, I think GTE means greater or equals. Yeah, it means, now we saw the 7 record here. So this syntax looks odd. It basically means that you write your query in as a JSON piece of data, and this is familiar to people who've used MongoDB. So this is the MongoDB style of querying your data. You could also just check for the existence of a field. So you could say fruity $exist equals true. Then it would show you these 2 records. The last one I inserted because they have the field fruity. And if I change the true to false, we should see all the documents which do not have a fruity value exactly here. So fruity doesn't exist, and we select it this way. So how is this being executed in our code? If we go back at our Node.js program, we have this method here called reviews, which is invoked whenever we load the table. And if we don't give it a query expression, then we return the documents of the entire collection. So collection.find get documents means find me all the documents. Versus if we have this QBE, the filter expression, then we just have behind the find, we do this filter to not select all the documents or only select those documents that match the filter expression. So this is to show that without writing any SQL, you can insert, update, there's also some delete. I don't think I have to show this now, and query your data in a NoSQL style, while at the same time you can use SQL to filter it, to access it later on. So now let's insert a bit more data. I've prepared a script to batch insert it. So this is now the REST way to work with collections. So for example, you can make a request to this URL and checking for update. I don't want you to check for updates now. And you make, these are HTTP requests. So HTTPs can be put, post, or delete. So if you do a delete request to this URL, you would drop the survey collection. If you have a put, so the syntax of the URL is such that you have a REST listener. This is part of ORDS, Oracle REST Data Services. So here you see the ORDS, this is the schema name, then SODA is the service, simple Oracle document access, latest is the version, and then we have the collection name survey. So this is how we would create it. And then if you do post requests, this is how we insert the data. So now if I run the script now, let's see where I have my REST, it's here. So I'm running now this batch insert, which is a bunch of individual inserts into the collection using REST. And if I refresh the application, then we should see, hopefully, yes, there is a bunch more. So now we inserted a lot more. This is, for example, the JSON for one record. I can pull it out. Or again, I can go to SQL, and now I would see that there are more, maybe make this a bit bigger, more records inside the database. So now we could use SQL to calculate certain things. So we see that people are willing to pay the most money for the black flavor. And we have 15 reviews for it, and they're willing to pay the least for the orange flavor. So this is just to show that you can use SQL. Yeah, we could, for example, create a view using the existing well-known mechanism of creating and replace a view with this query. And then if we query the view, we have access to the data without any JSON involved. So here, the JSON, the fact that the data is JSON is basically hidden. Yeah, so the second part is we also have Python. So I wrote a little Python demo. Now we have more data in it, so it makes sense to analyze it. So this is a Python program, actually the first one I ever wrote. So apologies if I made some mistakes, but it's similarly easy. So we have to import this cx_oracle. This is the Python driver, which now has support for SODA. I then wrote some visualization to plot correlation. So in this demo, I wanted to find out if there's a correlation between sweetness or bitterness and price. For example, to see if people are willing to pay more or less for a candy depending on the sweetness. Then here we create the connection to the database, we get the SODA handle, and we open the collection. And the next line here in 25 is we find the documents either with a filter or without a filter expression. So let's just look at all the documents here. So get documents without any filter. And then I iterate over the document. So now I have the JSON documents, I iterate over them, I extract the values for price, bitter, sweetness, and fruity. And then I plot a histogram about the price distribution and then the correlation. So it's kind of 50 lines of code. It's actually 50 if I remove this obsolete new line here. And let's see what happens if I run it. I placed it here. Sometimes I have to reset the display variable this uses. No, it works perfectly fine. So this 50-line program, what it do is this is the plot between, or for the prices. So we see that people are willing to pay between $8 and $16, a little more on the high end. And we see that if stuff gets sweeter, people tend to pay less for it. So the x-axis is the sweetness and the y-axis is the price. And bitterness, it seems that people are willing to pay more if stuff gets more bitter, and fruitiness seems less of a correlation. So now if I just wanted to not do this across the entire collection, I could say, well, let's do it with all the black ones, which are the more bitter candy. So I could just rerun the program here, and I'm running this now on a subset, so we will see less data points here, but the correlations are, I think, reinforced here. Yes. Let's say I wanted to exclude certain things, then I could just say, well, the price has to be greater than 5. I don't know if there was any, but let's say greater than 11, just to make a life change here. And let's see what effect this has. And so this demo is basically motivated towards a person that wants to use Python, either for visualization or for machine learning or for whatever Python is popular. And it's just meant to show that it's very easy to get access to your data sitting in the Oracle database. So basically these lines, you connect to it, and then you already have your collection, and then you can access your data and even filter it. So it's kind of 4 lines of code. All the rest has nothing to do with the Oracle database or generally with JSON, but rather extracting values and drawing them on the screen. Yeah, now going back to spanning the bridge towards SQL, we could now say, what is the rank of our survey? We use the windowing functions here, or the powerful analytics function in SQL. We see people like the most. And just to motivate that, because Oracle is a relational database, we also have joins. Let's say we had a table of sales data. So what we collected was survey data about, let's say, a new kind of candy. But let's say we're already selling that candy in other markets. We could then calculate the same ranking over our existing markets, and then just with a simple join, we could see, well, which market is the most similar to our survey. So we have our survey ranking and our sales ranking, and we select from both, making this a join. And then we could just use, by simple word clause and grouping, we could find out, well, what markets are most similar. And we see here that PL for Poland is a good match. So yeah, so this is the demo we gave at Open World, just to show the strength of JSON and the Oracle database, both for SQL use cases, but as well for very agile, dynamic web programming, kind of Mongo style, where you don't start with a table and a schema, but instead you say, I have a collection of X being cars or purchase order whatsoever. And as you go, you may change your data, meaning your JSON may get more fields, or fields are not longer be used anymore. But then, because everything is stored in Oracle, you're not, basically this NoSQL style access is an option. You're not forced to use it. At some point, you could say, well, now I need more powerful analytics and I use SQL for this. Or if you want to use joins, these drivers support joins. Yeah, that was the story we told at Open World in Code 1. So yeah, that's basically the demo. And I'm open to any questions. Do we have any yet?
Not so far. I just posted in the chat, so if anybody has a question, You can type it in the
Right.
chat, or if you would like to just ask it, I can unmute your mic.
It doesn't have to be related to this demo. I mean, I'm happy to answer questions regarding Soda, but you could also ask me anything else regarding JSON and Oracle.
Hi, this is Stu Ashton. Can you hear me?
Yes. Hey, Stu.
Hello. I have lots of questions, but I don't want to take over the meeting, that's for sure. I'll start with this. I know that the JSON standard says that it refuses to deal with binary, float, and double, infinity, and nan, and all of the parsers out there do different things. So I understand that you have difficult choices there. However, it seems that right now, the Oracle database does two things that don't seem to fit together very well.
Okay.
If I generate JSON from binary, float, infinity, binary, float, nan,
Yes.
NAN without quotes.
Yes.
I get INF without quotes.
Oh, you do get that? What version are you on?
18. On live SQL, you get that.
Oh, is that true? So you use JSON generation functions for that, or what do you use?
Oh, yes. JSON array, JSON object, whatever
Yeah.
you use, if you give it binary, float, infinity, it will output INF without any quotes around it.
Yeah, that would not even be valid JSON, I guess.
Well, and that's actually where my question comes in. It's doing that.
Yes.
And on the other hand, if you give that JSON back to JSON value or JSON table or any of the JSON reading functions, it says that it's invalid.
Sure, because it is invalid.
So
it is invalid.
I really wouldn't care if the two were coherent. I would not say anything.
No. I mean,
the incoherent.
It's not only incoherent, it's also incorrect. The JSON generation functions are meant to always return you valid JSON. And that, I think, is defined pretty well. By default, we accept a bit of lax syntax. So for example, by default, the key names don't have to be quoted, although by the standard they have to be. But I think what you're observing here is definitely a bug. But you said it's binary float and binary double. What about number? Oracle number?
There aren't, with a number, infinity and nan don't exist.
I see. Because I guess we did most testing on Oracle number and not a lot on binary float and double. But from your description, I'm pretty sure it's a bug, and I will file it after this meeting and assign it to the person who writes that code, and probably in a few days it's going to be fixed. The question is, how can we get you a backport? Do you have Oracle support?
Well, no, I'm retired, independent, and I just I do Oracle just to help out, and I speak at conferences, and I'm speaking on JSON soon.
Right.
So I like to investigate all this stuff.
No, that's perfect. So I'm pretty sure that the person who owns the code will have this fixed by the end of the week in our development label. But that still means that, it will get backported to all these bundle patches and whatever these patches are called. So people will get it as part of bug fixes. But
well, it would be enough for me if I ever mention this to know that for people who actually use this in production, that that it's been corrected.
Right.
Although,
So
I understand.
Right.
I understand that you're going to correct it in that way. I would almost wish you did it the opposite, because people, no one will know what to do with infinity and nan now, but except not ever use it.
Right. Basically, what you're saying is that the document looks like this, correct? I'm not sharing my screen. Sorry, let me share my screen again. So, can you see this?
It's capitalized.
Oh, it's capitalized. I see. Like this.
Yes.
All right. Yeah, yeah. So this is, I mean, this tool here, jasonlint.com. I've used it here in my demo for pretty printing, but you can also use it just to check syntactic correctness. I don't know that it's free of bugs, but I have not encountered one. So I kind of rely on that from time to time, like this one. But I would definitely say this is not JSON. So we cannot return this and claim it's correct. So then we have to think about what we do. One solution would be to do it like this. But again, I will have to ask the person who owns the code how he feels that this should be done.
Well, I just appreciate you taking that into account, and whatever you do is fine. However,
Right.
if people like me who don't have support could learn about that in some way, just so that we would be informed then of whatever your decision is, we would appreciate it.
I mean, you could send me an email, then I can inform you in person. I'm not sure if there's any mechanisms for me to inform people.
Oh, okay. Well, I'll send you my email.
Thanks a lot.
And I'll wait.
Yeah.
I have another question, but I'll wait if someone else wants to take a turn.
So you said it's infinity and not a number, basically. Okay, NAN. Kind of like that. Okay.
It's all capitalized. It's NAN,
Yeah.
INF, and -INF.
I see. Yeah, makes sense. Yeah. And you said binary double and float.
Binary double and binary float.
Okay.
Because float alone is just a kind of a it's a kind of an alias for number.
Right.
But
Yeah,
binary underscore but double and binary underscore float are the data types.
Yeah, yeah, I know this type. Yeah, I will. If you send me an email, I'll keep you in the loop what happens, and I will also send you the bug numbers so that you can refer customers to it, and they can then ask for a backport of the fix if they need it. Would it be accurate to say that OData is a counterpart to SODA? If so, what makes the SODA format better than OData? What measures were missing from OData? So I would have to ask, what do you mean with OData? What is OData? So SODA is not really a format. It's more like an API, a style to interact with a database. It's not a data representation or so. This SODA is something I've covered, I think, in the last 2 AskTOMs about JSON. So it's basically a layer on top of the database which abstracts your data model into documents inside a collection. And it gives you puts and gets, the basic CRUD operations, and we support REST, but REST is kind of just the channel. SODA is more the semantics or the protocol, and then we have Java and REST and Node and so whatsoever implementations of the format. So one limitation of REST is that it's stateless, so you can't do transactions, you can't do commits and rollbacks because REST is meant to be stateless. At least this is how we interpreted and implemented our REST driver. So that, I think, is the primary reason why we implemented other drivers. Conceptually, you could use REST to do anything, and from Python or Node, you could have just called REST, and it would have done the same. But it might be a bit inconvenient to handle the URLs all the time. So it works, but it may be less convenient than having a native driver for SODA in the programming language of choice. Sure.
I have been doing a lot of round trips with JSON functions, generating JSON from SQL, and then taking that JSON and reading it back into SQL to make sure that I got the same data back through the round trip process.
Right.
I like to do that with CSV and XML and things like that to make sure that I've got everything straight.
Yes.
And I noticed something strange. If I have a JSON object that is the value is a string, but it's a string in the ISO 8601 date format, okay, with
Yeah.
a date and a time,
Yes.
because it's generated that way by Oracle.
Yes.
And when it's read back, if I say that it's a date, then Oracle will just return the date portion and it will truncate the time portion. Are you aware of that behavior?
There is something in the back of my mind. I think so if you're saying returning timestamp instead, then are you seeing the entire date?
Oh, yeah, sure.
But if you say date, then the time information is truncated, you're saying.
Yes.
This might, again, I will bring this up to the person who writes the generation function, but isn't that the way
Well,
how
no, the JSON generation function generates the whole date time thing.
Sure,
It's not
exactly. Yes.
It's not the generation function is string.
Well, but the generation so the generation, let's say you run it from a date column or a timestamp column, then in both cases, the generation function would get you an ISO 8601 string.
Yes.
And in the first case of the date, I expect you will see a lot of zero paddings at the end for time information. Is that correct?
No, when it generates the date in okay.
When it generates the date, it's shorter. It's not using the precision, the entire precision of 8601. It leaves the date out. Or what is this thing? Does the string contain time information or not? Let me start it this way.
Yes, yes.
Okay.
Yes.
So
all of the JSON generation functions produce JSON that reflects all of the data in the original column.
Right.
So if I say JSON array sysdate, it will give me an ISO 8601 string where I see all the date and time information.
Right.
No problem. But if I read that back using JSON value or JSON table, and I say returning date, it will only give me the year, month, day part of that data.
That might be intended, because if you want that information, you would say returning timestamp, I guess. So if you do, have you tried that out?
Oh, yes, I have.
So I think it's...
Yeah, that works.
I would guess that this is expected behavior, that if you... because you get back a valid date SQL value, I guess. If you
yes,
say,
but the data type in the Oracle database includes a time portion. So it's
it's not really a date. It's not
developer.
A date, but it's also not a timestamp, right? Because the timestamp has more precision than the date.
Yes, yes. I mean, I agree. There is a confusion between the Oracle data type and the ANSI date.
Exactly.
The ANSI official date does not contain a time component.
Okay, but what you are observing is basically now, if you want to round trip it, let's say you have a date column which has more than the date. In addition, it has some time information. And you round trip this with JSON, then you're losing the time information.
Yes.
Yeah. I will ask the person if this is expected or if this is a bug too. It seems to me that we may want to fix this, otherwise it's not really round trippable unless you say on the way out or in one direction it has to be a timestamp. Yeah, well, very good.
Well, whatever. But if you don't change it, it would be nice to put something in the documentation, because it is surprising.
Okay. Yeah. Yeah, we'll do that, and I'll reply to your email and inform you about what we decide in that. So thanks a lot. This is really good.
Well, thank you. And there's another chat thing, so I'm through. Thank you very much.
Sure. Thank you, Steve. What performance issues might we expect? Are there particular operation or transformation that are particularly problematic, or put it different way. What are common pitfalls when doing SOTA stuff? Maybe something that seems to make sense in the traditional context, but isn't such a great idea. Great question. So SOTA gets translated to SQL. SOTA is a little layer or a veneer on top of the database that gets these QBEs, like the one I put here with a flavor, and translate that to JSON, to a SQL using JSON exists. And this means if you have an index, it will also get picked up, or if you wanted to explain plans, you can do that with a REST driver, for example, or you collect the queries in the database and you take a look at that. So the database doesn't really know that the query it's executing is coming from SOTA. It just executes random SQL, and the SQL just came from the SOTA rewrite layer. There is obviously then at that point, it's performance-wise, it's like any other JSON operation you're executing. So JSON exists would benefit from an index, so you can use a B-tree index to index one field. We don't have a multi-value index yet. So let's say you have a JSON with a collection. Let's say an example would be you have a person record and the person has an address, or normally has one address, so you put an index on the zip. This is the normal functional index on the zip field, but let's say now you have a cardinality change and you allow a customer to have multiple indexes. Then at that point, the normal functional B-tree index doesn't support multiple values per row, so we can't use it. So instead, we either use the JSON search index, which indexes everything. So we're working on path subsetting to only selectively index some fields, but right now we're indexing everything. Or you have to work with materialized view and do a bit of handwork or plumbing to get the performance there. So I would say there's nothing too specific about SOTA, but there are some things to keep in mind about JSON in general. So if you don't have an index and you're looking for a field, then the JSON needs to get parsed, which means that you read through this string. So right now in all our available releases, JSON is stored in the string representation, and it needs to get parsed byte by byte. And that is obviously more expensive than scanning through the Oracle row format. So you see the reading through the data being a bit slower. And there's one caveat: if you're looking for a field that occurs not in every document. So let's say you're looking for a field that does not exist, ABC, for example, then you have to read through your entire JSON in order to find out that it does not exist. JSON is not ordered. We do early termination. Let's say you look for, let's just open this record. Am I still sharing my screen here? I do, right?
Yes.
So let's say you're looking for a suite. Then once we found it and we read the value 70, we will not read the entire rest. So we call this early termination. But let's say you're looking for a field called XYZ. It doesn't exist here, but we basically have to scan the entire JSON to find out that XYZ doesn't exist. So indexing is certainly a good option here. Maybe I do one of my next AskTOM on indexing. I think I haven't had one on that. That's a good idea. You can always do partitioning. You can use sharding. All these relational tuning aspects still apply. So when I created this collection here, this was open. I said somewhere there is a create collection here. Yeah, create collection. So this will create a standard table. If I wanted to use partitioning or any other means here, I could also create this table by hand, make it look like a collection, meaning having the same fields and the same data types, and then just register this table as a collection. And it would also work with SOTA, but then I would be able to use partitioning, for example.